G'day YouTube, Warbles on a lot here, and it's a bit of a mad scientist style of a topic and a bit of a crazy ass clip, but I'd like to talk about relative temperature, okay, with respect to the third prototype SunFoil and its ability to use waste sun heat to drive a barometric thermosyphon powered cooling air pump to cool the solar panel. And the only way to prove that is if we start looking at the relative temperatures. So here we have a Digitech electric thermo probe which says it's 20.2 degrees, and here we have a mercury maximum minimum thermometer which actually more or less agrees, says it's 20 degrees. Okay, so over here in the clearing we have the car facing true north, being supervised by a kangaroo as usual. And well, what I'd like to do is begin with getting an air temperature underneath the panel. Right? So we take our little probe here and we put a sort of a bend in it, and then we reach in here until we get the probe touching the metal underneath the panel, which has not been in touch with any sunlight, and we get a temperature of 27.2 degrees. So it's been in the shade, but it's got heat leaking into it from the part of the car roof that is in the sun. Okay, now next bit that I'd like to check is the temperature of the air going up into these cooling air inlets. Alright, so if I can hold that in the centre with one hand, I'm coming back here and checking with the other. 31.5 degrees. Air temperature of the air going in. Okay. That's because there's radiant heat coming out of the bottom of the solar laminate. Now, maybe we'll come around to this position here and see. Now, up in there, there's a blast tube. And what I'm going to do is stick the probe up into the centre of the air coming out of the blast tube. Okay, and that gives us 33. Just hang on. While I turn that around so I can read it. 33.1, 33.5 degrees. And now we'll see what we get on the surface of the solar panel. Okay, so we're showing the panel is hotter than the air going out the outlet, which is as it should be. It's up around the 40, 39.8 anyway, 40, there we go. .41. Okay, and now let's see what the temperature is on top of the roof. Alright, now I'm going to have to move that back so I can read it. Will you turn around, you mongrel thing? Okay. And this is a fairly low angle sun. Earlier on in the day the roof of the car was about 13 degrees hotter than the panel on top. $38.5, $37. Just trying different points on the paint, see? Oh, look at that, 42. 43. 43.5 degrees. Paint temperature on the roof. Okay. So there it sits, apparently doing nothing. It's actually functioning as a waste heat driven solar thermal cooling air pump. What's that? Considerably cooler than the roof, surprisingly. However, it's not actually perpendicular to the sunlight, so that kind of could account for it. So, there we go. Some relative temperatures around the Mark III SunFoil. Now, midday, you get about 150 watts worth of heat driving the barometric thermosyphon driven cooling air pump. And of course, when you take this thing out on the highway, move it through the air at 100 kilometres an hour, the 16 ram scoop inlets forward facing, they get 13.68 litres of air per second going into them, and there's only room for 8 litres a second to come out at 100 kilometres an hour through the 5 blast tubes. So therefore the air inside the plenum chamber or hot box is compressed by 40%, and then it goes through the blast tubes. Its pressure drops by 20%, but its speed goes up by 20. And so at night you've got ram scoop powered boundary layer airflow control plumes to use coander effect to unstall the trailing facet. On a hot sunny day, you add 150 watts of raw solar heat to the airflow going through the boundary layer airflow control system, and the very small amount of solar thermal ramjet thrust increases the power and the efficiency and the effectiveness of the boundary layer airflow control, and it sticks more of the roof slipstream onto the rear window and reduces the drag profile of the whole vehicle. So it might sound like a silly idea to be bothered paying attention to such a small amount of power and a small amount of energy, but if you're going to enclose a solar panel in order to streamline it, then you have to ventilate it. Once you ventilate it, you might as well make that heat do something useful. Yes, hillbilly hybrid, including a solar thermal ramjet, which you can prove with an electric thermocouple. Ciao!